Let me put you over there, put the focus here. All right, yeah, so hello everyone. As I said, my name is Pierre Laporte. Thanks for having me today. I've been working at DataStax for 7 years now, so I've been involved in many topics. And so today I'm going to talk about how we used Chaos Mesh in the AstraDB serverless test. But first, let me do some introduction on who we are and what technologies we're talking about. First, Cassandra, maybe you already know about it. Cassandra is an open source distributed database. It's been open sourced in 2008 by Facebook. It's distributed under the Apache license. And it has a leaderless architecture in which no node has any special purpose, right? All nodes have the same roles. And that features enable two things. First, it allows linear scalability. So if your workload increases, you just add new nodes and call it a day. Second, it also enables users to have up to 100% uptime on their system, because even if some nodes are unavailable, the database itself never goes down. Now, you should already see how chaos testing Cassandra can be interesting, given such bold claims. One word about DataStax. It was created in 2010 to support Apache Cassandra. We still contribute to Apache Cassandra today. We support it, we develop our own commercial version, and we've been significantly involved in Cassandra development over the years, kind of like PinCap on TDB. And especially recently with the big testing efforts so that Cassandra 4.0 could be released as the most stable version ever. As part of our cloud offering, we have just created a data streaming service based on Apache Pulsar. And my colleague Enrico Olivelli did a presentation at Pulsar Summit on how we used Chaos Mesh in Pulsar distributed tests. The link is in the slide. I'll send you the links for the slides just after the talk, in case anybody is interested. And our database cloud database offering is called AstraDB. It's based on Cassandra. It runs on Kubernetes, and yeah, let's discuss the resiliency and the metrics. So there are multiple frameworks to do distributed system testing. In the database space, the most famous one is Jepsen. It's a framework that is focused on data consistency checks. It lets you verify that a database CP or AP claims are true as per the CAP theorem. And it works on standalone deployments. You have to give it the keys to your database servers with root access so that it can mess with them. And technically, it can provision servers based on CloudFormation templates, but this is limited to publicly available products. If you want to test snapshots of your products, you have to provision machines and configure them yourself. Now, that part is a bit tedious, so to solve it, we have created Fallout. And at the beginning of the call, you saw Guy, my good colleague, he's working full-time on Fallout. So he's one of the people who actually make this happen. Fallout is a layer on top of Jepsen. It's an open source project. And although initially it was created for Apache Cassandra, now it's a general purpose tool. Its goal is to enable repeatable experiment with real cluster in a declarative way. Fallout takes care of provisioning machines, it's optionally building products, installing, configuring them, and it orchestrates tests. It supports Kubernetes, it's integrated with GKE, and at the end of the test, it collects important data like logs, client-side latencies, server-side metrics, everything you need so that you can analyze the results. You can analyze what happened during the test after the fact. And although it's based on Jepsen, using Jepsen is not mandatory. Typically for our resilience test, we leverage another tool called NoSQL Bench. And I promise that's the last one I will present. NoSQL Bench is an open source load testing framework that we created as well. It was initially created as a replacement for YCSB, which has some measuring flaws and was hard to evolve. And so it's a load generator that supports multiple protocols like CQL, Kafka, Pulsar, and the list goes on. It takes a benchmark definition as YAML. It runs a requested operation, and then it measures latency and throughput from the client point of view. It also measures drivers dependent metrics if they exist, and it reports metrics in real time to Graphite, and at the end you get HDR histograms. Now that we have presented the tools, it's time to use them. Before we developed our tests, we identified several types of failures. We categorized them and found two main groups. First, there are the recoverable infrastructure failures. These are typically when some piece of hardware fails, like network card or disk drive, but it can also be when machines are stopped without notice, or it can be when there is a surge in client activity and we exceed a cluster capacity. The point is, these failures are recoverable, and they are mostly handled by the use of Kubernetes liveness probes and by the horizontal pod autoscaler. Misbehaving pods are killed and then recreated. Depending on the extent of the outage, by the way, we may or may not notice something from the user perspective. But yeah, that's the first kind, recoverable infrastructure failures. Boy, that's hard to say. The second one is disaster failures. Typically here, we are talking about a whole region going down because of a storm in US East 1, for example, or a DNS server in a whole region starting misbehaving, like in 2018, there was one in AP Northeast 2. And the list of AWS region-wide failures goes on and on. So what did we want to achieve when we implemented our chaos tests? The tests themselves are fairly simple to describe. We started a benchmark with NoSQL Bench against an Astra serverless database, and while the workload was running, we injected failures with Chaos Mesh. The main point of the exercise was to build knowledge and confidence in our product. First, we wanted to observe the resilience of the system. When the outage starts, is there a visible impact on client-side latency? And if so, during the outage, does the impact stay or is it quickly mitigated? As you can guess, we want the impact to be as low as possible and to be as short as possible. And the second part is we wanted to compute the MTTR, the mean time to recovery, which is how long does it take for the system to fully recover from the outage? One thing to know about these 2 points now is that they are handled differently. The Cassandra driver has some knowledge on the cluster they are talking to. And when a node starts being slower, the driver may speculate that the node will not come back, it will not respond. So the driver resends the in-flight queries to other nodes. And when a node goes down, the driver quickly reacts and stops sending it queries entirely. Now, this has some very interesting consequences. Suppose a node goes down. The queries that were being processed by that node will have a longer response time, but from the user perspective, they will not time out because the driver has speculatively resent them to another node and got a fast response. And from that moment on, the dead node is ignored. So from the user point of view, the impact is just a brief latency spike during a few seconds. But the reality is different because at that point, we're still running with one less node. The entire cluster has one node that is down, so we should do something about it. And the MTTR is about the cluster returning to its normal state. So it's about the pods to fully recover, to be fully restarted, and their liveness probes to return a valid code. This can take a lot longer than just the few seconds that we were talking about in the driver. And so the MTTR is much longer than that. Now, onto Astra Serverless architecture. As I mentioned, Astra Serverless is our cloud-native database offering. And there is a pretty extensive white paper that describes the architecture if you're interested. It contains a lot of data on how we implemented it. So here's a very, very short summary. It looks like this. We have the data plane where the user-facing interactions happen. We have the infrastructure services that maintain the cluster metadata as well as handle monitoring features. And finally, at the right of the diagram, we have the storage layer. Now, if we focus on what happens when client application sends request, they send it to stargate.io. This is an open source project as well, Stargate pods. And these pods support a variety of protocols like CQL, GraphQL, Document API, that kind of things. Stargate pods decode queries and request data from Cassandra pods that are data services over here. I hope you can see my mouse pointer, by the way. The Cassandra pods essentially compare it with the metadata that we have in etcd and fetch the data from S3. The data, by the way, is stored on S3 and local disk. Here is, it's not clear from that diagram, but this is how it works. We used Chaos Mesh in the AstraDB data plane box over here. We created scenarios to kill pods and affect network links. Actually, I should go on to the next slide. So we kill pods and we mess around with network links. And the way the pods we affect, or the network links we affect, are between pods themselves, so between internal pods of the data plane here, and also between these pods and external services like etcd and S3. Chaos Mesh is usually configured to inject an outage every 10 minutes or so for a long period of time. Now, once we had written the Chaos Mesh experiments we wanted to use, we automated everything. We love automation. We used the tools that I presented earlier, Fallout, NoSQL Bench, along with Chaos Mesh, and we wrote some logic to compute the MTTR. In terms of YAML, each test corresponds to a pod chaos or a network chaos experiment. And these experiments are injected in one or more pods. And to this day, the tests are run every week on our latest snapshots. So closing thoughts so that we have time for Q&A. We have many more ideas on what to test now. And typically one of them is creating Chaos Mesh-based tests for Apache Cassandra 4.0 on Kubernetes. And that would be leveraging the Cassandra open source project. Another one is augmenting our existing test harness with more experiments like AR Chaos or Stress Chaos could be one too. We are far from done with our discovery of Chaos Mesh. And I want to thank the community for such a useful tool. One last thing, we are hiring. So we are a remote first company. We have multiple open positions for developers as well as data architects all around the world. So if you'd like to work on a massively distributed database, here's my contact information. And feel free to drop me a message. And that's pretty much all I had.
Thanks, Pierre. I have this question.
Yeah.
You use the chaos experiments on your CI workflow or do other project?
Could you repeat?
You use the chaos experiments on your CI workflow or GitHub. When you merge a PR, you will run a chaos experiment, chaos test, or other workflow. What time you do this chaos test?
We do not gate the pull requests by the chaos tests. So how to say this? We do not prevent a pull request from being merged with the chaos tests. What we do is every week we take the latest snapshot version as per the develop branch, and we run the chaos tests against this version.
Oh, yeah, I got it. Oh, you just get a release version or just some git commit. You run this version every week. Just this, you will run it every week. It's like we use the chaos in AstraDB is same way.
Oh, okay. So there is such a system in Chaos Mesh.
Yeah.
Okay. Well, today I learned.
Oh,
I need to research that.
Yeah, yeah. Chaos Mesh is also when I do some tests when I use the Gibson. I do some tests with Gibson. I find it's difficult to use the Gibson. So I just describe, do some chaos and some for injection from Gibson, and then develop a project with Go to replace Gibson. So and this birth of the chaos mesh.
I see. Yeah.
Yeah, I think Gibson is very difficult for me. The Clojure is very difficult for me.
I think when Fallout was created, one of the very first idea was to have some abstraction on top of Jepsen, because Jepsen was very, very elaborate.
Yeah.
And it was not simple to get into.
Yeah. And at present, we also run Gibson test in AstraDB and maybe every week or just every day, just run Gibson test. And also we also run our new project. We call this Tapokit. It's use Go to build and to ingest the chaos and also to test the AstraDB. And in this new project, we run these two tests for the, yeah. Okay.
Hello, Pierre. I have a question. Hello, I'm Zhiqiang. I'm the coordinator of the Chaos Mesh, and I just noticed that you mentioned the automate everything. You say you could use NoSQL bench for running some test case, and you will calculate the MTTR automatically. And the question is, how do you do that? It's on it's a Jenkins pipeline, or it's a Argo CD or whatever other CI platform.
So the way we do that is through Fallout. In Fallout, you describe two things. First, you describe the clusters, the machines you want to use, and then you describe
Kubernetes cluster.
Come again? Could you repeat that? Oh, okay. I'll start again. So in Fallout, you start by describing the machines that you want to use. And yeah, it can be with in terms of Kubernetes flavors or machine flavors. You describe how you want them to be configured with Helm charts, and Fallout makes sure they are provisioned correctly. Then you describe the workflow of your test, which is, I think it is similar to an Argo workflow, although I do not know Argo very well. So yeah, it is Fallout that does all the orchestration, including the MTTR computation at the end. the NoSQL bench workload itself is, in my case, it's a series of read and write queries for which we verify the data that is fetched by every read query. So it's similar to what Jepsen does, although less precise, I'd say. Jepsen verifies that at any point in time, is it possible that you have received that value? With NoSQL Bench, we don't do such advanced thing, but we can verify the end state of the database. And for the MTTR, it's essentially, we record the time when the chaos events are injected. And how to say this? We keep the biggest value between user noticeable impact or cluster is back at full scale and all pods are running. Does it make sense?
Yes. I think I could understand it. And by the way, so all the test infrastructure is based on the Oracle. Yeah, if I heard correct, it's a PaaS platform or another thing. It's a cloud platform. It's a cloud provider.
Yes, yeah. The tests that we run, they run in the cloud. On we have some of them running on GKE, some of them running on Amazon. It's always Kubernetes based, but yeah, they run in the cloud.
Okay, I got it. And by the way, here is just a thing, a word that you mentioned. The tools, the name of the tools. I can't recognize it. How to spell it? It says something provides a workflow and let you configure your cluster. What's that tools? A fallout. Oh, sorry.
Fallout.
Fallout. Thanks. And I have another question. What kind of chaos are you ready to use? I mean, you inject the chaos into the internal pods, and what kind of chaos do you to use?
Today, pod chaos and network chaos.
Oh, the pod killing or the container killing, or other
pod killing.
Okay. Also, so you save many YAML file to describe that chaos then could be control apply -f. Okay. Yeah. I think I have that. And another question: where do you store that so many YAML file? It's on a config mapping, a Kubernetes cluster, or it's just a file of some certain host?
We store them on GitHub. We have a pretty large repository of tests. That repository contains not only chaos tests, but also performance tests. And so we store the YAML file, the chaos mesh YAML files, alongside the Fallout YAML files, because Fallout tests are described as YAML as well. So we locate the files close to each other.
Oh. Thanks. I got that. The reason why I ask this question is Chaos Mesh is Chaos Mesh want to build a platform that could management that some best practice of that YAML file. So it's a better way to tell user for.
I see.
Maybe Zhiqiang has some issue about this network. Yeah.
Yeah, it broke up for me as well.
Hi, Pierre. I have another question. Oh, I also doing some chaos experiments on TDB. So I maybe it's difficult for to verify the database how when do chaos experiments. Maybe we run some workload. Do you have any other ways to verify the status of the database? To check the status of the database when do chaos chaos experiments? How to check?
How to check the state of the database?
Yeah, how to check, how to make sure the database is right or have some issue when do chaos experiments?
Are you asking how we verify that the database contains the correct data?
Yeah.
Okay, so in NoSQL Bench, the way NoSQL Bench generates pseudo-random data, okay? So it's like if you have a random generator, except you always use the same seed, okay? So if you use the same seed, you will get the same value in the same order. So it means after the value 1,300,000, you know precisely the state of the database because the values that have been generated and stored, you know them in advance.
You know, you just run a workload to check your status of the database, or just check the database status by the matrix or other things.
Maybe I'm missing your question. Hold on. When you say the status of the database, do you mean the status of the data or the status of the nodes themselves?
I think when we do chaos experiments, we do such as we do a pod kills, make some to kill some pod, and then we will need to check the status of their database or the data of your database. And in this, you know how to check and how to verify the database is right, and maybe some data is lost or something is broken. Maybe in TDB we maybe run a workload such as bank to translation between the account in TDB, and also we verify from the matrix. I want to know, do you have any other way to check your status of the database? I just want to this. My question is this. You just run a case or just a workload or to check your database, or just to check the status by the matrix or other things?
So in terms, when you write a data, hold on. If you have a process to check the consistency of the data. Yeah, that's, so when we run a read workload in NoSQL Bench, NoSQL Bench verifies that the data it has received is correct.
Yeah. Oh, I know you use the NoSQL Bench to verify the database.
Yes, exactly.
Yeah. Oh, I got it. You just when do your chaos experiments, you run a NoSQL Bench to verify your database. Yeah. Is right?
Yes. Yes.
Oh, okay. I got it. You don't just use the NoSQL Bench. Don't use the matrix or other things to check to verify your database?
So if NoSQL Bench receives, how to say this? Hold on. So NoSQL Bench sends a read query, a select query. Mm-hmm. It receives data. If the data is not what it expects,
yeah,
it will mark the query as failed.
Oh, I know.
So the way we verify the consistency of the data is by looking that no query is marked as failed.
Yeah, okay, I got it. You just run this NoSQL Bench, use this case or workload NoSQL Bench to verify a database when do chaos experiments. Yeah, okay, I got it. Thanks.
Do we have any more questions for Pierre or anyone would like to talk about anything in general? If not, I'll have Chengwen take us through the technical updates in the past month. Chengwen, are you ready? You're on mute.
Oh, sorry. Yeah, okay. I will share my screen. Oh, can you see my screen?
Yep.
Okay. Moment. Yeah. Okay. Hi, everyone. I'm Chengwen. Thanks for joining this our community meeting. Next, I will show some technical updates about the chaos match in this month. Okay. And this month, we are developing a very important feature, which is also the key feature in our next version. And here is just a pull request, which hasn't been merged. In this feature, we will integrate chaos-D and chaos match together. So users can create chaos experiments both on Kubernetes target and not Kubernetes targets on a unified dashboard. And I'm also very looking forward this feature. And next is about the security. And in this pull request, users can use the GCP account to log in chaos dashboard. And this just the first step, and then we will continue to support more public cloud providers, and users can use the cloud provider account to log in chaos dashboard. And if you install chaos match on the cloud. And also during this month, we also do some work on refactoring. First, we refactor the API of the chaos dashboard and unify the API with in a RESTful style. And also we refactor chaos control component to improve the security and the scalability. This just prepare for to improve the first recurring feature. Okay. Okay, next is about release. In this month, in last month, we released a milestone version, and so in this month we receive a lot of feedback, and also we released the bug fix version, and here is a release note, and maybe this bug fix is very important, and because this issue maybe cause the failure when you run the stress chaos. If you encounter some issue on stress chaos, you can try to upgrade to latest version. Maybe this version will fix your issue. And also, if you have, and we welcome to more user to give us feedbacks when using our latest version, and this which is very useful for us to improve chaos match. And if you have any suggestion or you have any issue, you just create an issue on our GitHub repo or just create a pull request. Okay, and here this issue next is about planning. We will in this issue we trace the 2.0 version, and in this issue we list some our future plan and also release time. And here in next version we will improve workflow, and we will show the related chaos experiments and events on chaos dashboard when you view the workflow details. And also, and here, and this is key features, and we are developing it, and also I have introduced in previous slide. Oh, and also if you have any features you would like to see in this version, you just leave a comment on our GitHub on this issue, and we will discuss with you. If we have enough time, we also can add this feature on this version. Yeah. Okay, and here it's just if you want to try chaos match, you can click here to this is interactive tutorials. And in this tutorials, we'll guide you to use the chaos match to start your first chaos experiments step by step. And you don't need any environment because these tutorials will create a free Kubernetes cluster for you. And here is just some document about how to install chaos match. And we recommend to use the Helm to install chaos match on your production environment. And okay, yeah. And if you want to get more some document, you can find it on our website. Okay, hi Mila, come to you.
Thanks. I will share my screen. So recently, we are still in the process of proposing Chaos Mesh to incubation stage. And the update is that we've recently finished the first draft of our due diligence doc, and we're having our sponsor to look at it. And we also recently celebrated 100 contributors in the Chaos Mesh repo. So that's like, I believe that's a really good accomplishment for us. And we are so grateful and want to give you a big thank you to everyone for contributing to us. And we are also taking part in the LFX mentorship fall cycle. And I think Zhiqiang is the mentor for this monitoring metrics about Chaos Mesh. I think the application date is over, but we'll announce who's the mentees very soon, because I think it starts in September. And cool. And so we have a few blogs published recently, how Chaos Mesh helps API 6 improve system stability is a blog by Chaos Mesh and API 6 committer, Shu Yang. And also we worked on Chaos Mesh 2.0, which gives you a overview of what the new version is all about and what we're trying to accomplish in the future. And we also did a live stream with our chaos engineering evangelist Siam in the beginning of August, and Chengwen and Calvin took you through all the nits and grits about Chaos Mesh 2.0. And we also have an upcoming talk by a previous LFX mentee, Dave Brata, about new paradigm of resilience testing, cloud native chaos engineering at a conference happening in September, I believe. So make sure you sign up for that. And I think that's it for the community updates. And if we have any more questions that anyone else would like to ask, now is your time. So go ahead and ask away.
Yeah, and we also, if you have any new feature want to add in our chaos match, you also can comment on our GitHub issue. I also send the issue link on the checkbook. And any question?
And by the way, we will make the slides available on the meeting notes later after the meeting is over. So no worries.
Yeah, maybe if you have any suggestion or issue want to discuss in our community meeting, you just comment on our meeting note, and we will discuss on this community meeting. Yeah.
Also, I just sent the meeting notes to the chat. Oh, I saw a comment.
Yeah, I think it's also a good suggestion to integrate with observability tools. Oh, and also this in our plans. The first step, we also have a Grafana plugin, and but this don't we can't use it in new version maybe, and also this we in our plans, and you can find this plan in our roadmap. We will also to integrate more observability tools, and such as Grafana, Prometheus, and so on. And we will do this. Okay. Oh, if we don't have any other question, maybe we finish this meeting, Amila.
Yeah, if no one else has anything to add, I think we should just wrap this up. Thank you to Pierre and Guy for coming and sharing your experience using Chaos Mesh. And thank you everyone for joining us from all over the world, I believe. Yeah. And we had a great time. See you all next month. Thank you.
Thank you.
And good night.